Hi guys, this is Mr. Urrego, and today we're going to do radicals. We're going to add, subtract, multiply, and divide radicals. We're going to simplify them, so let's start. Square root 16, 4. Square root 25, 5. And these are perfect squares, right? That's what I'm doing right now. Square root 36, 6. So every time we're doing radicals, we think about perfect squares. So let me write all the perfect squares here on the side. So we have 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 25, 36, 7 times 7 is 49. All those are multiplying. 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 7 is 21, and this is 144. All these are perfect squares. Okay, so every time we're doing radicals, we think about perfect squares. Okay, why? Because it's easier to simplify. Okay, when we're simplifying radicals, it's easy thinking of perfect squares. Like I said, square root 16 is 4, 25 is 5, and so on, right? Now, let's get into multiplication. So let's pretend that they're giving me a problem, and that I have, let's change the color real quick. So let's pretend that they gave me square root of 6 times square root of 2. Okay, I'm multiplying two radicals with the same index. Oh, I haven't talked about index. So this is my radical. The symbol itself is called a radical symbol. Technically, there's supposed to be a tiny little number on here, which is called the index. Okay, if there's no number there, you have a 2. There's no number, you have a 2. A 2, okay? That's what we read that's what we read square root, okay? Number on the inside is called the radicand. 36 is the radicand, 25 is the radicand, 16 is the radicand. The little 2 index, all right? So if I'm multiplying two radicals with the same index, in this case, square roots, what I do is the inside, I multiply with the inside. So this will give me square root 12. Okay, but now how do I simplify that? How do I solve that? So I have to start thinking about perfect squares. Okay, what two numbers give me 12? What two numbers that when I multiply will give me 12? Which of these can I get into it? Yes, 4 times 3. 4 times 3 is 12. If you notice, I broke the 12 into two numbers, 4 times 3. Now, the properties of multiplications of radicals, they say that if I have two numbers multiplied inside a radical, I can break those into two separate radicals. Why? Because now I have square root of 4. Square root of 4 is 2. And the 3 is not a perfect square. Prime number stays inside. So 6 times square root of 6 times square root of 2, the final answer will give me 2 square root of 3. Let's try another one. They said that I have square root of 10 times square root of 5. Again, inside the radical. Therefore, I can multiply them because that's what's happening. I'm multiplying square root of 10 times square root of 5. Therefore, I get square root of 50. All right. But again, 49 is a perfect square, not 50. That means I have to break something 50 into two numbers, or 3 or 4, many more numbers. Right now it's probably 2, that one of them is a perfect square. So what I do normally is that I bring the 50 on the side and it says which two numbers, and the easiest one is divided by 2. Divide 50 by 2. 50 divided by 2 is 25, and check if by any chance that's a perfect square. Well, that's right, here we go. The square root of 25 is 5. So what's going to happen is I'm going to take that 50, square root of 50. I'm going to break it into two numbers, which is 25 times 2. And because I have two numbers multiplying, I can break them into two different radicals. Normally what I have is I bring the perfect square in the beginning. Why? Square root of 25 gives me 5. Square root of 2, this is a prime number, stays the same. And now this is my answer. Okay? If by any chance, so this is my answer. If by any chance you had square root of 2 times square root of 25, that's okay. Square root of 2, can I do anything with this? No, stays the same. Square root of 25, yes, it's 5. So what happens is this, when you have a number multiplying a radical, this number, because it doesn't have a radical, will become a coefficient. So I want to bring it into the front of the radical. So I'll put it in front of the radical. And this will be a coefficient for the radical. We don't want to keep it on the back, because sometimes what happens is you have square root of 2 times 5, and people get confused, and then they extend this radical and they put the 5 inside, and now it becomes a mistake. So we don't want to make that mistake. You have a number multiplied radical, you bring it to the front. Okay? So this is the properties of multiplication. I can multiply two numbers, bring it into 1, or break it again into 2. Now let's talk about division. Let me erase a little bit. So we're going to divide now. Same idea as multiplication. Okay? So let's say that I have two radicals. Square root of 50 divided by square root of 2. Okay. So by itself, square root of 2, there's nothing that I can do because it's a prime number. Square root of 50, I got to break it down and, So before I do anything and create more work for myself, I try to see if I bring them both on the inside. Okay, they're dividing on the outside, square root of 50 divided by square root of 2. I bring them as a fraction dividing on the inside, and I see if there's anything that I can do. Oh, 50 divided by 2. Square root of 25. It's square root of 25. My answer is 5. So sometimes knowing the properties will avoid a lot of work. Okay, this goes back and forth. If I have, let's pretend that I have square root 36. No, I need a bigger square root, right? So yeah, let's just make the bigger square root. Here we go. Square root 36 over square root of 49. Everything is inside the radical. Can I simplify those two, 36 and 49? No, divisible by 2, divisible by 3. This one is divisible by 7, so nothing you can do. So that will be it? No. It says, hold on, maybe by itself. 36 is a perfect square, 49 is a perfect square. So if I break them into two different radicals, again, they're dividing on the inside, they're dividing on the outside, but just separate. Square root 36, 6. Square root 49, 7. So back and forth. Two radicals into 1, one radical into 2. All right, back and forth. So I'm going to use those properties to simplify more radicals. So let's practice a little bit more. So let's say that I have square root of 200, for example. And the question is simplify. 200. Let's look at this thing. 100. Okay. I bring the 200 on the side. I know that if I divide by 2, I get 100. Oh, but 100 is a perfect square. Excellent. So I break that into 100 and 2. Why 100? Because the square root of 100 gives me 10. Square root of 2 stays inside. So whenever you have a radical and they ask you to simplify, you'll never use a calculator. Okay? You want to do this. Break the numbers into two numbers that you're able to do it. 72. I bring the 72 on the side. Divided by 2. Oh, 36. 36 and 2. And 36 is a perfect square. So there's going to be a lot of times that 72 I break into 36 times 2. But this, I can break it into two different radicals. And now square root 36 gives me 6 and square root 2 stays in. Right? There's going to be multiple problems like this that you're able to get into a perfect square, one of the two numbers. What about if I have variables? So let's get that's fine. So let's say I have square root of x squared, okay, which is x. How do I know how to do this? Okay, so the idea is the following. I got to work with the exponents now, okay? So when I did this perfect squares, that's fine, that's okay. But we need to understand why are those numbers coming out of the radical, okay? So let me explain real quick. So when I have a radical or square root, what happens is the following. As we know, this is the radical symbol. Technically, there's a little number on the inside. When there's no number, you have a 2. That's why we call this square root of whatever. This is my index, and whatever's on the inside. So let's do square root of 36. Perfect square, right? My answer is 6. Why? Because 36 is 6 times 6. If I'm going to write 36 as a power, I'm going to write 6 to the second power. Why? Because I have 2 6's. That's my exponent. 6 times 6 is 36. So 36 is the same as 6 squared. Alright, so let me replace here. Instead of 36, I'm going to write 6 to the second power. I want to make sure that I'm going to write the index. Right now, I don't have to, but let's just look at it. What's happening? So technically, when I have a square root, what I have is also a rational exponent. Alright, and let me explain the rational exponent. So let's pretend that I have, let's say, square root of x to the third power. And I want to rewrite this as a rational exponent. Rational means fraction. So my exponent is going to be a fraction. So let me change the color and let me use blue for the inside. So that x cubed, alright, stays the same. And my index is going to come up dividing my exponent. So that index is going to come up and divides my exponent. So square root of x cubed is the same as x to the third 3 over 2. Here, square root of 6 squared is 6 squared, and my index comes dividing my exponent. 2 divided by 2 is 1, and 6 to the first power is 6. And that's why square root of 36 is 6. Alright? All this to go back to my original problem. That. Okay. What is this? I said the answer is x. If this is x, if this x doesn't have an exponent, it has a 1, right? We don't put it, but it has a 1. Why does it have a 1? My index is 2. If I rewrite this as an exponential, right, rational exponent, I'm going to have x squared, and my index will divide the exponent. 2 divided by 2 is 1. When I divide my exponent by my index, whatever answer I get is going to be on the outside of the radical. Let me give you a different example. Let's say that I have square root of x to the fourth power. What am I doing? X to the fourth, and my index divides the exponent. What's my answer? 4 divided by 2? 2. So square root of x to the fourth power is x squared. Same thinking. X to the 10th power. What do? 10 divided by 2 is 5. So square root of x to the 10 is x to the 5th power. What I do is I divide my exponent. Okay? And this can help me do anything. I don't know. Let's say that I have cube root of x to the 15th power. Does it matter what's my index? No. Does it matter what's my exponent? No. Can I divide that? 15 divided by 3? Yes, I can. So that's going to be 15 divided by 3 is 5. So cube root of x to the 15 is x to the 5th power. Alright, so that's the idea about playing around my index and my exponent. So far I show you how to solve all of them thinking on perfect squares, which is fine. But sometimes I'm going to have different index. My index is going to be different. Right? Let me give you a different example. Let's say that I have cube root of 8. Can you do that? Do you remember how to do, perfect cubes? No. So what I do in this case is I take my 8 and I'll break it down. 8 is the same as 4 times 2. 4 is 2 times 2, right? And now my index is 3. So that means my index is telling me how many of each number I need in order for me to take one out. Let me explain. Let me rewrite this 8 as a power. I have, how many 2's I have? 3. So 8 is the same as 2 to the third power, 2 cubed. 2 times 2 times 2 gives me 8. So instead of this 8, I'm going to write 2 cubed. Okay, now let's think about the rational exponent. What do I do with my exponent and my index? That's right. I divide the exponent by the index. 3 divided by 3 is 1. So cube root of 8 is 2 to the first power, which is 2. So knowing how to go back and forth between a radical and a rational exponent will help me simplify any radical. All right, let's do something else. Let's say, let's keep it simple. Still simple. 81, no, let's do 27. Cube root of 27. Do I need to learn all the perfect cubes? No, you don't have to. But you need to know how to break the numbers. 27, and when I say to break the numbers, is the prime factorization into prime numbers. 2 is a prime number, okay? 27, 2 numbers that you multiply get 27. 9 times 3. 3 is a prime number. I got to break the 9. 3 times 3. Can I break those 3? No, they're prime numbers. So let me rewrite this as a power. I got 1, 2, 3 3's. Okay, so now I'm going to rewrite cube root of 27 is the same as cube root of 3 to the third power. What's happening with the exponents? They're going to divide. So I'm going to have 3 cubed. My exponent divides by my index. 3 divided by 3, my exponent, it's going to be 1. My answer is 3. So cube root of 27 is 3. That's the idea. Let me give you more examples. Now I have my index is even higher, 4. Okay, 16. 4th root of 16. The first thing that I need to do is break the 16. I know 16 is not a prime number, so I break it. 16. Anyway, 8 times 2 or 4 times 4. Got to break the 2 is a prime number. 8. 4 times 2. 4 is not a prime. 2 times 2. Okay. How many 2's I have? 1, 2, 3, 4. Alright, so instead of the 16, I'm going to say, alright, 16 is the same as 2 to the 4th power. Think about the rational exponents. My exponent will divide my index. 4 divided by 4. Alright, and it will be out. Oh, hold on. So let me write this just in case. 2 to the 4th, and my index divides my exponent. That's how I got to the 1. 4 divided by 4 is 2 to the 1st, which is 2. Right? So right now I'm giving you the basics, how to work with those. Okay, in the next video I'll go crazy with it. More numbers, bigger numbers, and how to take whatever we can out of it. Now to finish this video, what I'm going to do is I'm going to show you how to add and subtract radicals. Okay, so let's get to that right now. Adding and subtracting radicals. By the way, if you haven't subscribed to the channel, please do so. It's going to help me get the channel bigger, and that's the whole idea. We need to start streaming, so we need to go to 1,000 subscribers as soon as we can. All right, so here we go. Let's add and subtract. Add and subtract. So let me give you a basic example so we understand the idea. So let's say that I have 5 square root 3 plus 2 square root 3 minus 4 square root 2 plus, let's say, 10 square root 2. Okay. The first thing that you have to do is see, all right, hold on. inside my radicals, can I break those numbers down somehow? 3 is prime number, 2 prime number, inside the radical. Nothing that I can do. Okay, so there's nothing that I can take out of the radical. I'm ready to do. Now, the idea is the following. Think about like terms, okay? When we do in algebra like terms, you have 2x plus 5x gives you 7x, right? Like terms. If I have 2x squared plus 3x, are they like terms? No, they're different because they have different exponent, right? So they're not like terms. So this is your final answer. Same idea here. When we're doing radicals, my radical and the number on the inside have to be the same. The number on the inside is called the radicand. All of them are square roots because there's no index right there. So you have like tiny 2, tiny 2, tiny, tiny. We don't need to put it. So this is square root of 3, square root of 3, square root of 2, square root of 2. I do not care about the number that is outside. That's your coefficient. What matters is the radical and the radicand, the number on the inside. So this is square root of 3, square root of 3. So these two are like terms. Therefore, I can combine them because these are square root of 2, which is not. So how do I combine them? On the outside, 5 plus 2 gives me 7, square root of 3. This one's square root of 2, square root of 2. Excellent, like terms. Right? I can combine them. Therefore, negative 4 plus 10 gives me 6. Or 10 minus 4 is 6 of the same radical. And this will be your answer. They need to be like terms. Same radical, same radicand. Those are basic. Okay, let's do something more interesting. What about if we get something like this? So let's say that I have 3 square root of 8 minus square root of 32. Let's go a little bit crazy. 372 minus square root of 75. As you can notice, all of them are square roots because there's no number in there. So they're basic. I'm going to go back to the perfect squares, which is the easiest way. Okay, 75, not a prime number. I need to see what can I take out of it. Same 72, same as 32, same as 8. So first thing that you do is you break the numbers into a prime factorization. Okay, but remember, because these are square roots, okay, what I'm looking for is perfect squares on those numbers. What is my perfect squares? 1 times 1 is 1, 2 times 2, 3 times 3, 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 64, right? 81, 100, right? Those are perfect squares. So we're always thinking when you're doing square roots. What two numbers can I break the 8? Oh, I shouldn't, yeah. 4 times 2. Are any of those two perfect squares? Yes, the 4 is a perfect square. 2 times 2. So, I'm going to break the 8 into square root of 4 times square root of 2. Okay. Minus 32. Oh, that's a horrible term. 32 divided by 2 is 16. Ooh, 16. Here we go. 4 times 4. That's a perfect square. So I'm going to break the 32 into 16 times 2. Plus 3. What about the 72? Let's divide by 2. Okay, when I'm dividing by 2, I get the perfect square, which is great. 6 times 6. That's another perfect square. So 72, I'm going to break it into 36 times 2. 75. Let's go with 75. Can I divide by 2? No. By 3. Technically, I can divide by 3. 3 times 25. Right? What about the 25? Look at this, 25. Here we go. 25 is a perfect square. It's 5 times 5. So I break the 75 into 25 times 3, right? So that's the idea. I broke the numbers. I have perfect squares. Let me get rid of this for a second, and let's keep going down. As this is some advice. Every time you're doing math, try to work your way down, not to the side, your way down, so you can see the steps one after the other one. All right, 3 is on the outside, stays on the outside. Square root of 4 is 2. Can I solve square root of 2? No, stays on the inside. Square root of 16 is 4. Square root of 2 stays. 3 is on the outside. Square root of 36, 6. Square root of 2 stays. Square root of 25 is 5. Square root of 3 stays. Whatever number comes out of the radical, like that 6 for example, or that 2, and if there's a number on the outside, they multiply. So this is going to give me 6 square root of 2. There was nothing there, so it stays the same. Here there was a 3 times 6, 18 square root of 2, minus 5 square root of 3. Now we look at the numbers, and they're prime numbers on the inside, either prime numbers or numbers that you're not able to take out anymore. Okay, now let's do like terms. Square root of 2, square root of 2, square root of 2. That one is different, so it's not. So 6, we do the coefficients. 6 minus 4 is 2, plus 18 gives me 20, and the same radical, square root of 2. We use this 3 minus 5 square root of 3, and that is my answer. These two are not able to because I have a 2 on the inside, I have a 3 on the inside, and they're different. So you can combine them, and that will be my final answer. Alright guys, I'm going to stop here. Next video is going to be radicals and rational exponents, back and forth. Okay, we're going to do back and forth between those two because they're like family. They love each other. Alright, so we're going back to those two. That will be my next video. So stay tuned. Guys, make sure you subscribe to the channel, like the video please, hit the notification bell, and I'll see you in the next one. Take care. Thank you for watching. Bye-bye.